No lies, we've all been reading a lot of fantasy and horror fiction around here. And in today's space news, we found the universe is actually filled with monsters.
And because we like to share, today we're bringing you stories spanning from stars regaining their youth by eating the life force of other stars, as well as news of stars pushing apart planetary atmospheres.
We also have launches, yeets, and cosmic YOLOs. Want to know more? Stick around and find out.
I'm Dr. Pamela Gay,
And I'm Beth Johnson.
and we're here to put science in your brain, right here on the Daily Space. As we enter day 705 of March 2020, it can feel like nothing is changing during this never-ending series of Groundhog Days. And for those of you acknowledging it is February 4th, 2022, Puxahani Phil did see his shadow on the Groundhog Day. But anyways, while these work-from-home days all seem the same, some things are changing, like us. Kids are growing up, my gray hairs are multiplying, and day by day, moisturizer gets just that much more necessary. But what if we could find a way to hit rejuvenate, to go back to the most exciting days of our youth? Would you? What if it required you to consume someone else's life force? In a science article that reads like a vampire story, researchers found a massive hot star that looked like the kind of giant that should only live 5 million years. But this star was located so far from any potential stellar nursery that no one could explain it. Moving at normal orbital rates, this object couldn't have lived long enough to travel the 3,600 light years between it and the disk of the Milky Way. And trying to figure out how this young-looking star got to this far-off location, researchers realized this star, HD 93521, didn't form as one massive star, but rather as two smaller stars that traveled and aged together as a binary star system. Until they didn't. At some point, the stars merged together with one star consuming the other and rolling back its clock to become young again. HD 93521 gave away its murderous past with its spin. Pretty much everything in the universe spins, but it takes a violent event or a merger of some sort to get something spinning fast. And HD 93521 happens to be one of the fastest spinning regular stars in the galaxy. And it looks like HD 93521 may be a trendsetter. The stellar pair, IT Librae, is also zipping out of the disk of the galaxy, and one of its two stars looks entirely too young to have been able to make this journey. But a close look reveals that the smaller star is being robbed of its mass, allowing the growing companion to appear younger and younger as they journey. This work appears in a new paper in the Astronomical Journal and is led by Douglas Guise, and it concludes with one final bit of horror science. It turns out that these merging stars can evolve into fast-rotating black holes.
Black holes are hard to fully understand. In fact, the more I learn, the less I understand. The basic idea is simple. If the mass inside a volume gets high enough, the escape velocity becomes larger than the speed of light. Earth is a peephole hole since its gravity prevents me from jumping off. But at its current size, light can fly away. No big deal. Now, if you mash the Earth's mass down to about half an inch across, that much mass is in that small space is totally going to be a black hole. While stuff can't escape a black hole, forces like gravity can totally be felt across that event horizon, and calculating the tangled relationships between a black hole and any surrounding material requires understanding gravity, magnetic fields, and all of the relativistic versions of both. From looking at black holes, we know cool stuff is happening. Some systems flare up on a regular basis, including the supermassive black hole in our own galaxy, which flares daily in high energy light. We just didn't know why until now. In new research published in the Astrophysical Journal and led by Bart Ripperda, researchers show how magnetic field lines can pile up, tangle, and ultimately reconnect with a release of energy on a regular basis. As described in the release, quote, new simulations show that interactions between the magnetic field and material falling into the black hole's maw cause the field to compress, flatten, break, and reconnect. That process ultimately uses magnetic energy to slingshot hot plasma particles at near light speed into the black hole or out into space. Unquote. And when those particles fly out, they trigger those flares we see. This research was possible only thanks to the combined power of three supercomputers that increased model resolution by a factor of 5,000. According to Raperda, without the high resolution of our simulations, you couldn't capture the subdynamics and the substructures. In the low resolution models, reconnection doesn't occur, so there's no mechanism that could accelerate particles. Sometimes the answer actually is to enhance, enhance, enhance.
And sometimes the answer is to just proofread better. In the What's Up segment this week, we talked about the conjunction between the moon and Uranus. This event is occurring on Monday, February 7th. If you head out just after sunset, you should be able to find the moon about 2 degrees or 2 finger widths away from it. There's going to be just this little tiny faint dot that is Uranus. You'll need to use a small to medium telescope to really be able to make out the bluish-green dot to the right of the moon. The 11th, the date we falsely gave, snuck in from a story we didn't cover. The moon is going to be at apogee, its furthest point from the Earth, at 0300 UTC on February 11th, which is in the mid to late evening of the 10th, depending on what time zone you're in. At that time, the moon will be 404,897 kilometers away from the Earth, which works out to about 1.35 light seconds. We're sorry for the date confusion, but this correction lets us get in more science. From stellar vampires, we now turn to life, evolution, and the death of atmospheres. It's just that kind of a day. Stay tuned.
In our last episode, I talked about how researchers think the rise of oxygen levels here on Earth helped life come about, and how we could use that rise as a potential biosignature on exoplanets. I also mentioned that there are possibly a lot of ingredients that went into allowing life to develop here, and we're not sure which ones are necessary because of our sample size of one system with life. And our moon is unique in our own solar system. Its radius is over a quarter the size of Earth's radius, which is a larger ratio than other moons and their planets. Our moon stabilizes Earth's spin axis, which could have helped create a great environment for the development and evolution of life. When looking for that as yet unfound Earth 2.0, perhaps we need to also find the Moon 2.0 to go with it. To understand how necessary that aspect of the search may be, Miki Nakajima led a study of moon formations, which was published in Nature Communications, and concluded that only certain types of planets can form a moon similar in size ratio to our Earth moon system. Nakajima explains, by understanding moon formations, we have a better constraint on what to look for when searching for Earth like planets. We expect that exomoons should be everywhere, but so far we haven't confirmed any. Our constraints will be helpful for future observations. Our moon formed when a Mars sized protoplanet struck the proto Earth way back at the beginning of the solar system. This collision formed a partially vaporized disk of material around that proto Earth, and that material eventually collected together and became the moon mostly as we know it. To understand how other systems might form in a similar fashion, the press release explains, quote, Nakajima and her colleagues conducted impact simulations on the computer with a number of hypothetical Earth-like rocky planets and icy planets of varying masses. They hoped to identify whether the simulated impacts would result in partially vaporized disks, like the disk that formed Earth's moon. Unquote. And they discovered that rocky planets, which are 6 times Earth's mass, and icy planets the mass of Earth, will fully vaporize the disks in a collision, making the system incapable of forming a large enough moon. Nakajima concludes, we found that if the planet is too massive, these impacts produce completely vapor disks because impacts between massive planets are generally more energetic than those between small planets. As a result, we conclude that a completely vapor disk is not capable of forming fractionally large moons. So, a rocky Earth 2.0 needs to be smaller than 6 times the mass of Earth 1.0. That definitely narrows down the type of exoplanet we need to look for. It's great to narrow down what we need to be looking for as we search for Earth 2.0, but there's a teeny tiny problem. We have this gap in our planetary catalog between exoplanets about the size of Earth and planets 2 to 4 times the size, what we call mini Neptunes. So, if we're looking for something less than 6 times the size of Earth, we might be scrounging for targets. But 2 new papers in the Astronomical Journal may have solved that planetary gap problem. Well, not solved, so much as found out why it exists in the first place, which may not help in the search for Earth 2.0, and I really need to stop calling it that, but is still useful in helping to understand this whole planetary formation process that keeps confounding us. The new studies involve mini Neptune planets, 2 systems, TOI 560 and HD 63433. These systems are between 70 and 100 light years away or so. An analysis of the atmospheric gas around the planets shows that the gas is, well, escaping from them. That could mean that these mini Neptunes are becoming super Earths. And do you know what's awesome? We've suspected this was the case for a few years now, and it's great to get confirmation. As lead author and graduate student Michael Zhang notes, most astronomers suspected that young, small mini Neptunes must have evaporating atmospheres, but nobody had ever caught one in the process of doing so until now. Except one of these planets is losing its gas toward its star, which was not expected. There is a great possible explanation for this whole puffy planet to rocky process in the press release. Quote, many Neptunes are theorized to be cocooned by primordial atmospheres made of hydrogen and helium. The hydrogen and helium are left over from the formation of the central star, which is born out of clouds of gas. If a mini Neptune is small enough and close enough to its star, stellar X rays and ultraviolet radiation can strip away its primordial atmosphere over a period of hundreds of millions of years. This would then leave behind a rocky super Earth with a substantially smaller radius, which could, in theory, still retain a relatively thin atmosphere similar to that surrounding our own planet. Unquote. That's not to say there aren't other possible explanations for the planetary gap, but these new discoveries strengthen the evidence for the transition hypothesis. Meanwhile, on Earth, rockets are still going up, satellites are going into orbit, and astronauts are still training to go into space. Eric is going to tell us all that is going on in the world of space exploration next. Stay tuned.
On February 3rd at 1813 UTC, the Starlink 4-7 mission launched atop Falcon 9 booster 1061 from Launch Complex 39A at the Kennedy Space Center in Florida. The third Falcon 9 launch in the last 7 days. This was only the 6th flight for Booster 1061, which successfully landed on the drone ship, a short fall of gravitas stationed several hundred kilometers downrange. The Falcon 9 used the southern launch corridor, again, to take advantage of the calmer waters for recovery as it headed towards the 53.2-degree inclination orbit. This launch set a record for fairing reuse, with one of them on its 6th flight and the other on its 4th. And now to another launch that happened to be from something already in orbit. Also on February 3rd, the first satellite from Bahrain, a CubeSat called Light 1, was yeeted from the ISS by the GEM small satellite orbital deployer attached to the Keeble module on the ISS. The purpose of Light 1, a 3-unit CubeSat, is to measure terrestrial gamma ray flashes. These events are potentially hazardous to humans and machines. Let's watch that yeet. Future lunar spacewalkers won't have to worry about terrestrial gamma ray flashes, but they have a whole other set of concerns. Engineers and trainers at NASA's Johnson Space Center have been preparing NASA astronauts for extravehicular activities, EVAs, or spacewalks that they will need to perform during the future Artemis lunar landings. I was drawn to this story after seeing this really cool photo while I was doom scrolling Twitter. Basically, engineers want to know how to use the new spacesuit being developed for the missions and what tools the astronauts may need on the surface of the moon. Have other methods for trying out things, but trying to move around in a spacesuit in low gravity and do tasks is another matter. There's nothing like the real thing, or as close as we can get to the real thing on Earth. The EVA preparations have been going on since at least September 2020 and have consisted of building a simulated lunar surface at the bottom of a special pool known as the Neutral Buoyancy Laboratory. This latest phase of the training is practicing for an EVA at the lunar South Pole where it is permanently shadowed. Artemis 4, which will land earlier than 2024, will target this area. This is different from the EVAs done during the Apollo missions, which were closer to the equator and better lit. In order to simulate the lighting conditions at the lunar South Pole, they turned off the lights at the Neutral Buoyancy Laboratory. I'm not sure I'd want to do an EVA in almost complete darkness. This has been the Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the generous donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.